Have you ever wondered how astronauts get drinking water on the ISS? Consider this. It costs $83,000 to send just 1 gallon of water to the International Space Station. Now, factor in that each of the 4 astronauts up there needs 12 gallons of water per day for drinking and other uses. The bill for NASA, you might imagine, would skyrocket into the stratosphere. But here's the reality. The constant shipment of water tanks to the ISS is simply not feasible, not to mention astronomically expensive. Instead of sending water all the way from Earth, NASA has had to devise a more sustainable solution. And what's this ingenious solution, you ask? Well, let's just say it involves a complex water system that leaves no drop of available drinkable liquid wasted. Intrigued? Stay tuned, because we're about to dive deep into the fascinating world of water recycling in space. With costs that high, shipping tanks of H2O constantly to the International Space Station simply isn't feasible. So, if we can't ship water to the ISS, how do astronauts stay hydrated? The answer lies in the station's intricate water system. Let's delve into the specifics of this fascinating system. It's designed to extract every possible drop of drinkable liquid from the environment. This includes shower water, astronaut sweat, and even urine. Yes, that's right, urine. But before you cringe at the thought, consider this. The system is incredibly efficient and the water produced is clean, safe, and tasteless. Every droplet of moisture, whether it's from breath, sweat, or urine from both humans and research animals, is collected. Even the runoff from sinks and showers is gathered. It's a process of ultimate recycling, and it's vital to keep the station hydrated. Now you might be thinking, but how does it taste? Well, according to Layne Carter, who manages the ISS water system from the Marshall Flight Center in Alabama, it tastes like bottled water. The challenge, as you might imagine, is psychological. Can you get past the thought that the cool, refreshing liquid you're sipping is recycled urine and condensate that comes out of the air? Here's the thing, in space, every resource is precious. The cost and logistics of transporting supplies make it necessary to find innovative ways to sustain life. The water system aboard the ISS is a masterpiece of engineering that ensures astronauts have access to this most basic of human needs, regardless of the original source. And if you're still feeling squeamish about it, remember that on Earth, all water is recycled in some way. Every time it rains, you're witnessing nature's own purification system. The ISS's water system is simply a high-tech version of the same process. Yes, it might be a tough sell, but as one NASA manager puts it, it tastes like bottled water. Interestingly, not all astronauts on the ISS drink recycled urine. The ISS is divided into 2 sections, each with its own water system. The station, you see, is a testament to international cooperation, with one side run by Russia and the other by the United States. And as you might expect, each side has a unique approach to the vital task of water recycling. On the US side, the system is all about squeezing every last drop out of the available resources. It collects condensate, runoff, and yes, even urine to create about 3.6 gallons of drinkable water per day. It's a testament to the ingenuity of NASA's engineers, who've managed to turn what would ordinarily be waste into a precious resource. The Russian system, however, operates a bit differently. The cosmonauts prefer to process water from only shower runoff and condensate passing up the urine. This results in slightly less than the 3.6 gallons produced on the US side. But it's not wasted. In a show of interstellar camaraderie, the NASA astronauts sometimes pop over to the Russian side of the ISS to collect the Russian supplies of urine to process it themselves. In addition to these recycling differences, the 2 sides of the ISS also take different approaches to disinfecting their water. Since 1981, NASA has been using iodine, a process that requires the water to be filtered due to the potential for excess iodine to cause thyroid issues. Russia, on the other hand, has been using silver as a disinfectant since the launch of the Mir station by the Soviet Union in 1986. These contrasting methods showcase the ingenuity of both space programs. Each has developed a system that maximizes efficiency while ensuring the safety and health of their astronauts. Though their methods may differ, the goal remains the same: to make the most of every drop of water available. As we look to the future, the question of water in space becomes even more pressing. With eyes set on distant horizons like Mars and beyond, the challenges of water supply and recycling take on a whole new dimension. Imagine a journey to Mars, a trip that could take anywhere from 6 to 9 months one way. Now consider that each astronaut on such a mission would need about 12 gallons of water per day. The sheer volume of water needed for such a trip is mind-boggling, and the cost of transporting it from Earth astronomical. So, the focus shifts to more efficient water recycling systems and, potentially, sourcing water from the destinations themselves. Researchers are already exploring ways to extract water from Martian soil, or to find and utilize underground reserves of water on the red planet. Back on Earth, NASA and other space agencies are also hard at work developing more advanced water recovery systems. They aim to increase the percentage of water recycled on spacecraft from the current 85% to as close to 100% as possible. The goal here is to create a closed-loop system where every drop of water, whether it's from an astronaut's sweat, breath, or urine, is captured and reused. In this context, even the smallest of innovations can have a significant impact. For example, NASA is currently developing a new type of toilet that can capture more urine for recycling, thereby reducing the overall water needs on a spacecraft. As we push into the final frontier, the role of water in space becomes increasingly vital. It's not just a matter of quenching thirst or maintaining hygiene. It's about sustaining life and enabling long-duration space travel. As we continue to push the boundaries of space exploration, finding ways to efficiently use and recycle water will remain a vital necessity.